Hey guys, this is Anish Namalkanti, and for today's topic, I'm going to be talking about reducing of global warming by tracking carbon footprints. Global warming is a serious threat which can lead to increase of sea levels, to a decrease in person's quality of life, and global warming is caused by the increase of greenhouse emissions in the atmosphere. And a report by the United States Environmental Protection Agency states that more than 66% of the greenhouse gases released in the US are caused by residential and commercial, transportation, and electric power usage. So, for this, I propose a database solution which can help individuals track their global warming emissions because normally they are not aware of how much damage are they causing to the environment. And for the proposed database solution, I'm implementing a cloud database. And in this, I'm going to be using vertical fragmentation to divide the data in based on the type of data and the structure of the data. And I divided the data into five parts. Using this approach, I divided the data into user, transportation, energy, food, waste, and sustainability. I'm using a hybrid approach for the databases for storage. I'm using a MySQL and MongoDB to store the data depending on whether it is structured or unstructured or uh, semi-structured, and I'm using Apache Spark for the processing of the data to map reduce and to give predictions of the carbon emission based on the historical data of the user. And I'm also implementing a recommendation system to give recommendations to the user based on his historical data so that he can use the recommendations to decrease his carbon emissions. And all this process data would be stored in Cassandra so that it can we can have a faster retrieval of the data. So the users will input their data manually using a mobile app or web interface. I'm also using a bunch of IoT integration to get more accurate data, like I'm using smart meters, wearable technologies, and GPS trackers to track various usage data like energy use, transportation patterns of the user. And for the preliminary data set, I'm taking the data from Environmental Protection Agency and I'm using data from Department of Energy. This is the architecture of my database. I'm storing user and sustainability data, which is more structured data in the MySQL, and I'm storing uh, transportation, energy usage, food, and waste data, which contains logs and more unstructured, semi-structured data in the MongoDB. And I'm storing the pre-processed data using Apache Spark in the Cassandra wide column database. So I could get like faster retrieval and I could get real-time insights without having to take data from the databases and pre-process them again. I'm using Apache Spark for data processing because it processes data in real time, and for the MapReduce it can handle large scale data processing and calculations. And by using MapReduce, I'm planning to calculate carbon footprints of the user based on the data they gave and the logs we collected from the IoT devices. And I'm using Spark ML library for the recommendation engine and the prediction model. So the recommendation engine takes the historical data of the user and recommends five things that user can change to decrease the carbon emission. And the prediction model also uses the historical data of the user to predict what carbon emissions can they expect if they continue to do the things what they're doing. So for alternative approaches, I consider several technologies, but each had their own limitations, such as I use Spark instead of Hadoop because Hadoop can be good for batch processing, but it lacks the real-time capabilities which Spark has. So the user cannot be able to get more accurate recommendations or insights if I used Hadoop instead of Spark. And using a no only MySQL model wouldn't work because then the database would struggle with scalability issues when the user demand and the size of the dataset grows. And similarly, using a NoSQL model wouldn't work either because it cannot manage the relationships which are present in the structured dataset. The key features of this project are the real-time insights. User can get the real-time insights of the carbon emission data, which could be done by using Spark. And we provide users with a user-friendly dashboard of the carbon emission data, which they can understand easily and take actions. And also the recommendation engine, which provides recommendation to the users of how they can decrease their carbon emission based on the historical data, which is also visualized using in a user-friendly way to show them the potential impact of the carbon emissions, making it easier for the user to understand and act on the data. So this system offers users with an interactive dashboard that helps them visualize their carbon footprints, and the interactive dashboards are made using Power BI and Matplotlib to create a user-friendly and easy to understand dashboards, visualizations, and in the dashboards we present them with weekly and monthly trends to identify the behavior patterns and if there are any areas they can improve in. And we also break down the trends by categories based on the categories like energy, food, transport, waste, and sustainability practices. For example, so that they can see if in energy they are using more gas or are they using less renewable energy when compared to their normal electricity, what percentage of renewable energy are they using when compared to their electricity usage. And we also give we also provide them with a comparative analysis where they can compare their emissions with their community or people that they know, so we could encourage them to be competitive and bring positive changes in their lives. And there are also recommendation visualizations in which we provide them with recommendations on how to improve their how to reduce the carbon emission footprint, and also we give them a graph to show what what kind of changes what kind of impacts would that bring on their carbon emission if they act on it. And also we also equip them with the predictive emissions predictions in which we forecast their emission trends using the historical data and help them understand the long-term effects of their actions and help them plan proactively. This is an overview of how system implement things. So we collect energy usage data from the houses using smart energy meters and other IoT devices, and users manually enter the data through the mobile app or web interface. And we also collect their GPS and transportation data using the IoT devices on them, like wearable devices. So all this data is stored in the hybrid cloud database using MySQL and MongoDB. And then we process the data using Apache Spark. And the data which is processed is stored in Cassandra database for quick retrieval. And we also provide insights using the same process data. And when there is a need for the historical data, we take the data from Cassandra and then we give output using the data. This problem requires attention because global warming, which is caused by carbon emissions, is a serious threat which is responsible for endangering ecosystems and causing damage to human health. And many people are not aware of their carbon footprints or how their actions in their daily lives contribute to the increase of greenhouse gases in the atmosphere. And a research from the Journal of Environmental Psychology shows that personal feedback is like a powerful motivator for sustainable behavior, and this system helps others individuals know how their contribution affects the environment, which can help them bring positive changes in their daily lives, leading to decrease in global warming and reduction in carbon footprints. I'm using a cloud database using tools like Apache Spark and IoT devices to collect and process the data and using hybrid databases to address the scalability and flexibility requirements of the system. And using this, I'm planned to bring change, use providing individuals with recommendations to reduce their carbon emissions and predictions to help forecast and make them understand how their actions are contributing to the emissions of carbon footprint, and also providing them visualizations to understand how their actions in their daily lives are contributing to the greenhouse effect and causing global warming. And using this, I think there will be impact where people will follow this and there would be an encouragement in eco-friendly behaviors and bringing of healthier environments. And I also think it would benefit individuals and stakeholders to reduce their carbon emission and foster a culture of sustainability. Thank you.